How y'all doing? Don back here again with another video, and today we're gonna learn Go. We're gonna learn Go fast. Small disclaimer: this is meant for someone who has some basic knowledge of programming from, say, another language or something. So I'm going to be using basic programming terminology. If you have no idea what the hell I'm talking about at any point, you should probably go look up another video that tells you the basics of programming, things like variables, loops, arrays, stuff like that. So first thing you need to do is install Go if you want to use it on your system. You go to golang.org here. There's a big ass blue button here. You click it to download the installer or archive that you need. If you get stuck, you can go to documents and go to getting started, and it will kind of walk you through it. Instead of also installing it, if you wanted to, you can click this little link here called Open in Playground, and it'll basically give you like a web-based text editor that you can use to just mess around with Go for a little bit. Actually, this would actually be perfectly fine for everything that we'll be doing in this little video. So with that, let me go back over to my terminal. I'm gonna create a file. Doesn't matter what you call it. I'm just gonna call it tuts because it's a tutorial. I'm smart. I have like a tooling in my editor that's already kind of like put in like some boilerplate here. And this is like the actual very basic structure for creating a executable Go program. And let's go over everything here. So the first line in any Go file is the name of the package it belongs to. In the case of the entry point of a Go program, it has to be called main. Otherwise, you can kind of call it whatever the hell you want. Keep in mind that within the same level of directory, every file has to be in the same package. If you have like within your folder or directory, if you have 3 files, and let's say like file 1, file 2, or say they were in package A, and then the third file, since it's in package B, it won't be able to build. It'll yell at you. This is how you import, excuse me, other packages into your file to use. This is from the standard Go library. If you're going to be importing multiple things, instead of having like 20,000 import statements, instead what you can do is you can have import and then open and close parentheses and then the name of your imports. Each new import would just be a new line, like errors, it'd be like that. That's all you would do. It got rid of that automatically because my plugins like automatically running stuff to like clean up my file when I save. And then the entry point is a function, and functions are defined with the func keyword, followed by the name of the function. In this case, the entry point is called main. It has no arguments and has no return type. And then this case it just prints out a message. We're gonna replace that with the classic hello world. That's not, oh wait, why is that there? Okay. And we're gonna run this and go, hello world, okay, hello Moto. So this is now you can at the very least like run a Go program, right? So what's the first thing you want to do? Well, you probably want to store data in some variables, okay? So Go has 2 syntaxes for messing around with variables. The first one, you use the var keyword, the name of the variable, so we're going to word, and then the type of the variable. Go is a strong statically typed language, so you have to basically every variable has a type assigned to it, and then depending on what the type is, in the case of a string, you can't say assign an integer to this later, because if you do and you try to run it, it's going to complain at you. After you've declared your variable, you could say like word equals, and then we'll do hello world. And then instead of this being in here, you can say word. And if we run this should be good. Okay. So you can also initialize this with a value instead of making it later. So like hello world. This should still do the same thing. There you go. If you actually don't initialize this, now in most languages that you've probably used, this would probably throw an error saying, well, this is uninitialized, it's null, it's something like this. So in Go, pretty much every type that I know of off the top of my head has no concept of like null. When you try to reference a variable that has not been initialized, it's kind of implicitly initialized to what's called a 0 value. Every type has a 0 value. In the case of strings, it's basically just an empty string. If it's an integer, it's 0. If it's a boolean, it's false. If it's an array, it's just an empty array, things like that. So actually, if we actually run this, if I saved it, yeah, you'll notice it's just empty. A quicker syntax to work with, and because we're all good programmers, this means we're lazy and we like to type less, is if we get rid of this, you can do the name of the variable, colon, equal sign, and then whatever the value is. Now you'll notice that I didn't actually say what type it is. When you do it this way, Go will actually infer what the type is from the value assigned to it. So, and just to verify that it actually is inferring correctly, if I then later try to say, well, this is 5, and then I run this, it's going to cry at me saying that I'm trying to assign an integer to a string. So that's the very bare minimum that you need to mess with in terms of with variables. Let's say that you want to store a series of values though, so you want to use like an array or something, right? So let's get rid of all this stuff. Let's say so we want a collection, and it'll be actually we'll do this one, var collection equals square brackets, and then inside the square brackets you want the length of the array, so 10, actually 5, yeah, 5. And then the types of the values stored in the array, so let's say int, they're all integers, okay? And then let's say I want to set the value of the value in index 1 to 5, and then we're going to print out the array. And run this, and you see 0, 5, 0, 0, 0, like pretty much every other programming language I've ever used. Arrays are 0 indexed, so the first value actually has an index of 0, not 1. You can also use the same shorthand syntax with this. So it will be collection equals 0, 5 int. Oops, that's not right. 0, 5 int, and then curly braces. And then you can define all your values here. So I'm gonna say 1, 2, 3, 4, 5. Yeah, 5. Do it, yeah. And then we're gonna get rid of this, and I'm gonna run this, and 1, 5, 3, 4, 5 because I changed the value. So Go has a much easier way of working with arrays. So if you actually go here and I get rid of this, this is what's called a slice. A slice are basically I basically call them like smart arrays. They're like an abstraction over the standard arrays, and they also allow you to do some extra functionality that standard arrays don't use. So if I actually run this should be the same thing. One of the things that you can do is that it'll dynamically grow and shrink as it needs to. Kind of like how I believe if you're from Java, there'd be like what's it called, a dynamic array or something like that is kind of like grows and shrinks as needed. I believe somewhere in Go's documentation, it does basically say that unless you have a very specific reason for wanting to use specifically an array, 99.9% of the time you should just be using slices. One of the things you can do with slices is you can use a built-in function in Go called append. So if we want a collection to be something else, we'll call the collection equals append, and then the original thing, and I'm going to append onto it the number 10. And if we go over here, you'll see that it appended it correctly. Note that append does not mutate the original array. It does not mutate the original slice. It gives you back a new copy of the slice. So what else do we got here? So if you're from using other languages, instead of arrays, and something else you might commonly use is something that stores things in key value pairs. In PHP, this would be like an associative array. In Python, this would be a dictionary. In Java, this would be like a hash map, something like that. So the way you do this is I'm going to have collection equals, and I believe it's make, and then you have what is this? It is map, and then in here you have the type of the keys. So we'll say a string, and then the type of the values the keys are pointing to. So we're going to say int. And I think this has a 0 value too. Yeah, so it's just an empty map. And then you can assign values to here using kind of a syntax that looks similar in PHP. So we're gonna have collection hello equals 1. Then we have collection world equals 2. We save that and run it. You'll see hello 1, world 2, right? What else we got here? You can also remove a entry from here by using another thing called delete. So first you pass in the actual map, excuse me, and then you pass in the key. So we're gonna get rid of hello. So you run this and it's gone. It was never here to start with. You can also, if I recall, there's a kind of a shorthand syntax for initializing a map with values. And I don't recall you use make. Instead of that, you do like collection equals map string. Let's go this way. Yeah, okay, int. And then open curly braces. And I usually kind of do this on new lines. So it'd be like a hello 1, and then world 2. And then we're going to get rid of these. And I'm going to run this. No new variables unless oh yeah, whoops, let's get rid of this. Okay, that still works. So here's a little quirk that's interesting with Go. If you're like defining initial values or something in multiple lines like this, it actually makes you leave a trailing comma at the end of this for if you were to put like more values afterwards. See, if I actually do this and I run this, it's actually going to complain. Unexpected new line, comma, or curly braces. So it actually makes you do that whenever you're like defining stuff on multiple lines, which is interesting. It's just like a little quirk that that Go does. Okay, so you can store single values, a list of values, and a excuse me, and a map of values. So what else do we want to do? We want to how about you want to be able to do conditionals? You want if statements to be able to like have your program do different things depending on conditions. So just have standard if syntax. Unlike most languages that usually wrap the actual like condition in parentheses, you don't do that in Go. So I'm going to say like what if collection at hello is greater than 3, which it's not. I'm going to fmt print line greater than 3. And then you also have else if collection hello is, let's see, greater than 2. Oops, that's not, yeah, greater than 2. fmt print line greater than 2. And then you also have else, which will just, let's see, else. And I'll just say, oops, no, what are you doing that? Okay. fmt print line, I'll just put else. Okay, yeah, I'll do it. So if we run this right now, it should give you the else statement. Else, yep. And if let's say I go up here and I change this to 4. This should give you the first one, greater than 3. If I change this to 3, run this, greater than 2. Okay, there you go. What else we got next? Loops. So you wanna keep doing, you wanna like iterate over something a lot. So let's get excuse me, let's get rid of all this junk. So Go is a little unique in that it only has one type of loop, which is for loops. You're probably like, what? That doesn't make any sense. Well, it'll make sense in a second. So the syntax for it is kind of standard for most of our languages. So we're going to have I equals 0, while I is less than 5, I plus plus. And I'm just going to print it out, print line. I'm just going to print that out. It might suck. Okay, 0, 0, 1, 2, 3, 4. But you can basically make these for loops kind of behave more like other types of loops in other languages. So if you wanted this to basically be a while loop, you would get rid of all this junk and this and this. And I'm going to move this out here. And I'm going to do I plus plus. So basically this is basically saying while I is less than 5 to keep iterating. And then here I'm just increasing I inside the loop itself. So this should still do the same thing. Yep. What else we got here? So something else you can do with these for loops is you can actually iterate over a range of like a collection of values automatically. So if we have our let's say we have a array or a slice. So we have a slice of ints. Now we have 0, 1, 2, 3, 4, 5, right? And you can say, let's get rid of this. And we're going to say for, and it'll return two things here. It'll return the index and then the value. I guess, right? So for equals range over x. I want to print, index equals, and then index, and then value equals value. I don't need this. When you pass in multiple values like this to like print or print line, each one of these will have a space separated, I believe. So if we run this, you'll see index value, blah, 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 blah. Something you can do when you have something that's giving you multiple values like this, and this also works with something I'll show you later, is let's say we don't care about the index. This is rather common. I've done this quite a bit. Let's say we don't care about the index. Something you could do, so if you leave this alone and I don't actually use the index, I just use the value. If I do this, Go's going to complain at you because you declared a variable but didn't use it. You can actually tell Go to ignore a value by replacing the name of this variable with an underscore. This is basically telling Go, I don't want this shit third away. Now if you do this, now it's fine. You can also do this, this is the exact same thing with, let me go back a little more. Instead of this being a array, a slice, you can do this also with maps. So if I say this is a map with string and ints, and I say, what is this, 1, 2, 2, and then instead of this being an index, it'll be the key. I should just do, yeah, key, change word. That's what I wanted. Stop it. Stop it. Change word. Thank you. Okay, whatever. Key. And I do this. You'll see key 1, value 1, same thing. And again, if you don't want the key or the value or something, you can just put an underscore here to basically tell Go to throw the shit away because you don't want it. What else we got here? One other thing with the for loop. So there is basically what I guess you want to call a infinite for loop, which is basically just like for. So when you do this, you have to explicitly tell Go to break out of the loop, otherwise it'll just loop forever. So a way you would use this, so let's say I have I equals 0, fmt print line I plus plus, and then if I is greater than 5, do it please, break. So what this will do is that when I is, you're telling Go to explicitly to break out of the for loop, otherwise this will loop forever. Okay, there you go. So that's another neat. That's basically like your infinite loop you can do until you explicitly tell it to break out of it. Let's see. Let's get out of here. What am I on next? So we already did variables, conditionals, arrays, and slices, maps, loops. So let's make some new functions. How about that? So we've been in main the whole time. Let's make some new functions. So let's, again, if you see up above, to define a function, use the keyword func, and then the name of the function. So let's do basic math. Sum, yeah, we'll do sum. And then you say what arguments there are. So in this case, we're adding numbers. So let's say we actually want some arguments. We're gonna say what x is an int and y is an int. And then here you specify the return type of the function. So we're gonna say returns an int. And then it just does, it just returns x plus y. That's all it does. And then here we're going to say fmt.println sum of 5 plus 5. And we run this, 10, yay. So small time saver tip, if you have a function definition like this and you have multiple arguments in a row that have the same type, instead of explicitly saying what they are each time, you can actually do this. Do this. Yeah. So what do is Go will infer that these are both integers. So like this, see, that runs. And you can do this with as many as you want. So let's say we said this was like, it had 3 arguments and did plus z, and I did plus 1. See, still runs. And you'll notice I'm only telling it once what these types are, because it's basically inferring that, oh, all 3 of these must be integers. Say, excuse me, let's get rid of this function here, because we're going to do something else. So functions, if you kind of garnered from whenever we had the little range keyword, functions can actually return more than one value at once, which is pretty interesting. So let's say, so square root. If you take square roots in math, the square root of a negative number is like a complex number, and it's not really something we want to mess with, right? So let's say we're going to define a function, excuse me, called square root, and it takes a float, yeah, float, float. Can't spell words today. Float 64. And returns, and if it has more than one, you wrap it in parentheses like this. It's going to return a float 64, and let's return an error. See, this is a very common thing you do in Go, where if a function basically has the possibility of erroring, you return the main thing you want to return, and then an error. So we're going to do what if x is less than 0. We're going to return 0 because we're not doing anything, and then so there's 2 common ways that you can create and return errors. Excuse me. One is to use the errors package, and it has a new function, and then you put in the error message. Just to say x cannot be less than 0. Else we're going to return the square root, which I believe has a math package, and it should have a square root function, so I'm just going to use that. And even though we're not returning an error, we still have to technically return something here. So if you're not actually returning an error, you just return nil, which nil in Go is the equivalent of like null in PHP and JavaScript, or none in Python. So we're gonna go, excuse me, we're gonna go here. I'm gonna say I is equal to 5, and I'm going to fmt.println square root of 5. Actually, that's probably gonna complain at me because that's not a float, probably. Yeah. Wait, I is, oh, duh. You genius. Yeah, I need to do there. See, now it's a float. Okay, and you see it says nil for the other part. Yeah, something I didn't do here, which I have to do because I'm being a big dummy, is this return 2 values, right? I had I in error is square root of, oh wait, I'm doing this dumb, equals 50, equals square root of I. Yeah, I'm gonna call this x, yeah. I'm gonna print x. I'm going all over the place, man, I swear. Okay. So if you're returning an error, if I recall correctly, you have to handle it. If you don't check this, I believe the Go, it won't actually compile. Undefined G. Oh yeah, G down. Okay. Let's see if it yeah, error declared but not used. Actually, so instead of saying not used, remember you can throw stuff away. Let's throw it away. I think it might return a warning. No, okay. Well, if you're getting returned an error, and you don't handle it, I believe the runtime just panics if it actually gets an error. So to handle this properly, what you do is you're going to do if error does not equal, nil. By the way, you're going to do this so damn much, this whole if error is not nil thing, you'll probably write your own convenient way to basically just slap this in somewhere because you're going to do it a lot. We're going to do what fmt.println, there was an error. So right now there won't be an error, but if I make this -5, now it's going to go, there was an error. Okay. So another way you can do this is instead of doing errors.new, the FMT package that we're already using actually has a function that returns a formatted error message. So to do that, instead of using errors.new, we're going to do fmt.errorf, and we're going to do the value of x percent f excuse me cannot be less than 0, and then I'm going to say pass in x, right? Yeah, I think that's good. So I'm gonna run this again. Unexpected cannot be. Did I make a doo-doo? Oh yeah, you big genius. I stuck more parentheses in. I stuck more quotation marks in here. Get out of here. Okay. Let's try it now. There was an error. Oh yeah, so instead of actually saying just saying there was an error, I could just actually print out the error message. So instead of using print line, I'm going to use printf, which is similar to errorf down there, but it's just returning a string. It's not actually like returning an error. So I'm going to say there was an error, and then print out the error, which will be error. Oops, I actually want this on. Go. I want this on a new line. If we run this, you'll see there is an error. The value of x -5 cannot be less than 0. And so that's how you create new functions, return more than one type, return errors, handle errors, things like that. One other interesting thing you can do, and I might goof this up a few times because I don't remember how you do this exactly off the top of my head, is so instead of just having return types here, you can actually define the name of variables here. So let's just say this is we're gonna call this the root. I'll just call it the root, and we're gonna call this one error. And what this does is whenever this function is called, it will implicitly create these variables. Okay, and then what you have to do is instead of doing excuse me, return here, you just set these to a value. So we're gonna say like, okay, as of course, like any other variable, these are initialized to their 0 values, which in the case of a float is 0, in the case of an error is nil. So in this case, we would do error equals fmt, this basically this. We're gonna set it to this. So what is it? So this, yeah. I'm going to yank this, and I'm going to paste this here. Get rid of this. I'm going to get rid of. No, don't do that. Okay, and I'm going to get rid of this. Okay, and I'm going to do else. Let's see. Root equals math dot square root of x. So I think that works. I don't think you have to return in those. Okay, we do. So you just do return. So this is like a different way of doing it. It's a little weird. You don't typically see it used when you're returning errors. You typically see this used when you're returning like multiple actual values. So like if this function was returning like say 2 floats, you might see this used. An example of this being used that I remember off the top of my head, if you go to the time package in the standard library, I believe there are a couple places in there where it makes use of this like predefined variable name syntax in the return types of the function. So this should still work. Yeah, okay. It's just a different way you can do it. So we did functions, we did errors. So I'm gonna get rid of all this gobbledygook here. Get rid of the. Okay. So as Go is strongly typed, you can define your own types. A type you are going to very frequently probably do is called a struct. A struct is basically just like a has a predefined shape of multiple pieces of data. Think of it like a class in an object-oriented language like Java, but it doesn't have the behavior attached to it. So I'm going to have type user struct curly braces, and then here you have the name of the property and then the type of the property. So we're going to say, excuse me, name is a string, and then ID is an int. Yeah, we'll do that. And then so down here you would do like my user equals user, and there's 2 different ways you can initialize them like this. If you put it on a single line, you could just do like Bob 5 like this. And I'm going to do fmt.println. I don't remember if I can actually do this like this or not. My user. It might complain to me. It did. Okay, so you see it just has these 2 values in the struct, Bob and 5. If you are going to initialize these values on multiple lines, you have to specify the property name first. So it'd be like name is Bob, and then ID is 5. Again, you have to have the trailing comma or it'll scream at you. Yeah. If you want to access only a specific property on this struct, you do it with dot notation, so like dot name. This will only give you the name. If you want to change one of the properties on here, you do the same thing. You would say like my user dot name equals Bob Dole. Okay. What else we want to do here? Excuse me. So you can do other things with types. You can actually have types that are based on other types that are already in the system, and I'm going to show you why you might want to do that in a second. So you have say you want to type, and I'm gonna maybe a user has an email, and you want it to be a string. So we want these email strings to have some specific behavior to them, and I'm going to show you how we do that. So I'm going to say type email is a string, which this probably looks a little weird at first, and then instead of just saying this is a string, we're going to say this is an email. Yeah, like that. So what does this matter? So let's say this email is bob@bob.com. Yeah. That's a lovely email name. So remember how we've been making functions? There's an additional part of a function declaration syntax you can do that is a little unique to Go. So you can actually do what would amount to an object-oriented-ish type of approach, where you're attaching behavior to your types, and you do this through what's called a receiver. So you define your function like normal, like this. So we're going to say the name of the function is called, we're just going to call it validate. It's not going to take any arguments, and I'll show you why. And it's just going to return a Boolean. So how do we tell Go that this function belongs to the email type? Well, before the name, you do this. You have parentheses like this, and you name the thing it's attached to. So I'm gonna call it E for email, and you say it belongs to the type email. Now within this function, the thing it's attached to that you're calling it from will be like available. So like I don't want to pull the regex off the top of my head, but let's just assume that the email the email is always right, and it's going to return true. So you've attached behavior to this type you've created. So let's go down here and we'll say like if my user.email.validate, which I believe that should just be that should count as true because it evaluates the true or false. Do fmt.print line. This is a valid email. Oops, why do that? Oh, what do? Oh, but okay. Wait, didn't do all that. Right. Sometimes I get butterfingers on Vim so hard. Else, oh God, else fmt print line. This is not a valid email. And I'm gonna excuse me. I'm gonna get rid of this stuff. So we're gonna run this, and you will see this is a valid email. It called a behavior attached to the type we created. Now, what happened, and again, you would have like more proper logic in here, like you'd use like regex or something to check whether this is actually like a valid email string or not. We'll say it's false right now, and we'll run this, and it'll say this is not a valid email. So that's how you would attach behavior, like behavior to this. Now, you don't usually see it done to things like this. You usually see it attached to structs, because essentially attaching functions to structs is the closest thing you essentially get to like object-oriented programming in Go. Go has no concept of classes like you do see in like Java or something like that. It kind of like dissuades you from being like super object-oriented with it. So you can kind of force it to do that, but it's a little clunky. So what else we got here? Tags. So in structs, you can kind of define this like metadata type stuff called tags, and you do that by having what's that called, backticks. And one of them, what these are for depends entirely on your project. Some third-party dependencies will use them to do certain functionality. The most common one you're going to see is you're going to see this thing called I think it's JSON. And I think, is that how that works? It goes JSON, then like name? I think that's how that works. I might have field, but it's not export. Okay, yeah. Okay, so, since it brought this up, I'll make mention of this. In Go, like let's say this was a package, like a separate package that it was not an executable, and you wanted to make like this structure available for someone else to use in their code. The way Go does this is you don't explicitly tell it to export it like you say do in JavaScript with like the export keyword. The way Go infers whether something is supposed to be exported or not, or like made public, is whether the first letter of the name is capitalized. So if this is now exported, excuse me, if the name of your like function, your type, whatever, if the first letter of it is capitalized, it means it's public. It'll be publicly accessible outside of this package. But if it's lowercase, as it's pointed out here, this is not exported and is not public. And you'll notice it's kind of referencing a specific error, and what that's referencing is it wouldn't matter what the JSON tag is if this is not exported. But you're probably wondering, so what does this JSON tag actually do? So what this does is there is a JSON package in Go that allows you to encode and decode JSON to and from Go structs like this. By default, it will just try to match up the JSON fields with the names of the properties on the struct. But if you want it to be like a specific syntax or it has like a completely different name, you can define that in here. Hold on, let me do something real fast. My compositor is going crazy right now. Please stop. Okay. So like instead of this, you could say like, well, in my JSON file, it's not called name, it's called first name. So what that'll do is if you try to decode a JSON message into this particular shape of this particular struct, If it has a field in it called first name, it'll put that value in the struct. That's basically what tags are for. They basically add some like metadata that other packages can use to do certain behavior with it. See what else we got here. We've done variables, conditions, arrays, slices, maps, loops, functions, errors, creating your own types. Something else that I personally have done with these type aliasing thing like this is let's say we frequently do something like this where we have let's say like a map of users. So like let me put in this so it actually not cry at me. So say like users equals map int of user. Oops, user, yeah, like that. Something like this, right? Do this, yeah. So let's say you do this a lot, and sometimes you just don't want to write this out all the time, and maybe you also want the type name to kind of be more, I guess, semantic of what it's actually meant to be, to what it's actually like holding. So something I see frequently in some other projects is you can just create type aliases as kind of like shortcuts to things like these very specific like map type definitions. So I could have like type, I'm gonna call it like user map, and it's a map of type with keys of int, and they hold users. You basically do that. So then instead of me saying that this is a map like this, I can say it's a user map and do that. I think I'm running out of stuff here. So I guess last thing I'll do is pointers. So in Go, you can actually make use of pointers. Let me get rid of all this junk here because I'm not really using it now. Okay. Go down here. Thank you. So let's say we have a number here. We'll just call it x equals 0. And we want to pass it into a function called sum again. It takes a x and a y that are ints and returns an int. And all it's doing is returning, x plus y, right? And we want to, excuse me. See, and we just do this. We just do sum of x, and then we want to fmt print line. Actually, no. Actually, let's not do that. Let's do we want to do like increase, yeah, we'll do that. Increase int. Actually, we'll say it doesn't even return anything. We'll just do that, and it will do x plus. Yeah, let's do this. That makes way more sense. Let's get rid of this. Okay, so we're gonna do increment x. So what you may think happens is that okay, increment x. So this should be 1 now, right? Oops, not Compton. Okay. Oops, it's still 0. Why is that? So this function signature like this, this is what's called doing passing by value. What this function is getting is a copy of the value in this variable to use within this what's called a scope. But once you leave the scope, it was only usable within that particular function invocation, and then it was gone. It didn't touch this at all. If you're wanting to mutate the value of this original variable, you have to do what's called pass by reference. And to do that, you're basically passing in a memory reference to annotate that in the actual function definition. What are you doing, Mocha? My cat's losing her damn mind. You put an asterisk in front to indicate that this is a pointer, and then to pass in the actual memory address, you put an excuse me, an ampersand in front of this. This basically gives you the memory address of this variable, not the value. And in order to actually properly increment this, we need to let's call it dereference it with an asterisk in front. If you don't do this and you just do this, what you'll be increasing is the memory address, not the not the value that the memory address is pointing to. Because so I'll show you an example. If let's say I print this. Does it work? Yeah. So you see it printed out like a bunch of gobbledygook, but that's basically the memory address of that variable when this program. But if we do this now, you will see that the value has indeed been mutated. I'm not really going to go a lot over pointers. That's just to kind of like to show you how you would how you would use pointers. Fun fact: if you have whenever you're defining types, you can actually say that they so like you say you have a struct. Let's say we have I don't know, type my struct. Instead of this being a let's say a counter is an int. Instead of saying this is an int, you can actually say this is a pointer. You can actually have the structs be holding pointers, not the actual values. There's a couple of reasons why you might want to do this sometimes. Maybe performance related stuff. Maybe you want to do very complicated things with this. I don't mess around a lot of this with like very specific memory man stuff, so I don't really mess with stuff much. But just food for thought that you can do that. I believe at this point, that should be all you should be able to really need. At this point, you should be able to write a very simple Go program. You can, you can store data and variables. You can store, excuse me, a collection of values in arrays or slices and maps. You can do, your standard conditionals, if statements. You can loop with a for loop or with the range operator. You can create new functions. You can return multiple values from those functions. You can return errors and handle the errors. You can throw away values from functions that return multiple values if you don't need them. You can create your own types. You can attach methods to those types to allow them to be used specifically within like that type. And you can you can pass stuff around by excuse me, by reference instead of value. That's all I got for this video. There are a couple other more advanced Go topics I'll talk about in later videos, such as concurrency, maybe setting up like a development environment, dependency management is interesting in Go too. But that's all I got for this video. If you liked the video, if you're on YouTube, be sure to drop me a like and subscribe. If you're on Facebook, be sure to drop me, I guess what would be a like too, like and follow. But above all, the best thing you can do with this video is to share it so that it can help someone else out. And with that, y'all come on back now and I'll see you next time.